Hello everyone. Today we will discuss about the derivation of rate of flow through Venturimeter. Basically, Venturimeter is a device used for measuring the rate of flow of a fluid flowing through a pipe, or we can say that with the help of Venturimeter we can measure the discharge flowing through a pipe. To derive this expression, we have considered one venturimeter which is fitted horizontally in a horizontal pipe as shown in this case. Let us say that water is flowing through this particular pipe. Now as we know that the venturimeter is having three components. First one, it is the converging cone. Second one, it is the throat, and third one, it is the diverging cone. Okay, now to derive it we consider two sections, first at the inlet and second at the throat. So for this case we considered d1 as the diameter at section 1, P1 is the pressure at section 1, V1 is the velocity of fluid at section 1, A1 is the area at section 1, and similarly D2, P2, V2 and A2 are the diameter, pressure, velocity and area at section 2. Now to derive this expression we need to use the Bernoulli's equation. Bernoulli's equation, it is nothing but the addition of pressure head, kinetic energy head and potential head. So for this case, for section 1 we having the addition of first head, that is P1 upon rho g, which is nothing but the pressure head. Second one, it is the kinetic head, that is V1 square upon 2g, and third, that is the datum head or potential head Z1 is equal to, for second section we will write the same expression, that is P2 upon rho g plus V2 square upon 2g plus Z2, which is nothing but the addition of pressure head, kinetic energy head and potential head. Now as our venturimeter it is fitted in a horizontal pipe, or our pipe is horizontal one, then in that case we can say that this Z1 and Z2 is same. So our equation is modified as P1 upon rho g plus V1 square upon 2g is equals to P2 upon rho g plus V2 square upon 2g. Now you can simplify it by P1 minus P2 upon rho g is equals to V2 square minus V1 square upon 2g. Now this particular term, that is P1 minus P2 upon rho g, it is nothing but the difference in the pressure head at section 1 and 2. Now in this case we have shown the difference in the pressure head at section 1 and at section 2 by H. So we can say that we can replace this particular term P1 minus P2 upon rho g up with the H. So H is equals to V2 square minus V1 square upon 2g. So we have mentioned here P1 minus P2 upon rho g is equals to H, which is the difference of pressure head at section 1 and section 2. From now we need to apply here continuity equation. Our continuity equation says that discharge flowing through section 1, that is discharge flowing through this particular section, is equals to the discharge flowing through section 2. So here discharge, it is nothing but the product of area into velocity. So product of area into velocity at section 1 is equals to product of area into velocity at section 2. Okay, so from this equation we can find out the velocity at section 1, and velocity, that is velocity at section 1 is equals to A2 into V2 upon A1. Put this value in equation 1, that is put the value of velocity at section 1 in equation 1. So we will get, after simplifying it, V2 is equals to A1 under root of A1 square minus A2 square into under root of twice GH. So from this we know that discharge, it is nothing but the product of area into velocity. So put the value of velocity in the equation of discharge. So discharge is equals to A1 into A2 upon under root of A1 square minus A2 square into under root of twice GH. This expression, it is the theoretical discharge. This expression is used to find out the theoretical discharge in Venturimeter. But if you want to find out the actual discharge, but obviously the actual discharge it is less than the theoretical discharge, then the actual discharge can be found out using the equation Q actual is equals to CD, where CD is the coefficient of our Venturimeter. Q actual is equals to CD into Q theoretical, which is the formula of Q theoretical we have written, that is Q theoretical is equals to A1 A2 under root of A1 square minus A2 square under root of twice GH. So if you put here, then Q actual is equals to CD into A1 into A2 under root of A1 square minus A2 square into twice GH. Okay, now we have here two situations. If a liquid in a manometer is heavier than a liquid flowing through a pipe, for example, let us consider a water is flowing through a pipe and the manometric liquid is mercury. Then this particular pressure head or difference in the pressure head can be found out, H can be found out using the formula H is equals to X in bracket SH upon H0 minus 1, where SH is the specific gravity of heavier liquid and H0 is the specific gravity of flowing liquid. Now if we reverse the case, that is if the liquid in a manometer it is lighter than a liquid flowing through a pipe, then the formula become H is equals to X in bracket 1 minus SL upon H0, where SL is the specific gravity of lighter liquid and H is the difference of a liquid column in U tube.